Distance, Rate, and Time. Topic 12-5, Envision Math 6. For this topic, we need to understand what a formula is. A formula is like an algorithm. It is a rule that uses symbols to relate quantities. The formula we're going to learn today is distance equals rate times time. So D is the distance, R is the rate, and T is time. We're going to look at a sample problem and see how these relate to each other. Okay, in this problem, it says the students traveled by bus for 250 miles to the regional championship that is 2.5 hours away, and they were going 50 miles per hour. So, if you look here, we have our unit of distance is miles, the unit of time is hours, and then the rate is a combination of distance per time. That's why we have miles per hour. You combine the miles and the hour, which are two unlike units, and you put per in between them. Let's look at some other measurements of distance. You might have something like feet or yards, maybe inches or meters or even kilometers. What about time? Besides hours, you might also have seconds or days, months, years, or decades. Now for our rate in the center, we are simply going to combine some units of distance with some units of time. So we might have feet per second or kilometers per day or even meters per hour. So those are all examples of distance, rate, and time. Okay, we're going to use this example and solve a problem. This is just like doing an algebra problem. This is going to be an equation. We are going to be given two of the variables, and we're going to solve for the third. So we're going to look. It says Leilani is flying from Los Angeles to Honolulu. If the flight takes 6 hours and the distance is 2,574 miles, what is the average speed of the airplane? So first off, we need to input the quantities that we are given. And then we are going to use the rules that we learned for solving equations in algebra. The first rule we always had was to get the variable alone. So we want to take the unknown quantity and have it on one side of the equation by itself. And then the second rule was we always wanted to use that golden rule, which states what you do unto one side, you must always do unto the other. So let's input the information that we have. We've got distance. The distance is 2,574 miles. That is our D. Do we have a rate? We don't have a rate because I don't see a per anywhere. So it looks to me like the rate is the unknown that we are searching for. And do we have time? Yes, our time is 6 hours. All right, so now we need to look at our equation. right here, the rate and the hours are being multiplied. So I'm going to use that inverse relationship to get rid of the hours. What is the opposite of multiplication? It is division. So I am going to divide by 6 hours. And of course, if I'm doing it to one side, I must also do it to the other side. So I need to divide by 6 hours here. The 6 hours on the right side of the equation will cancel, which leaves us with just the R for rate. And then on the left side of the equation, I have 2,574 divided by 6. So I'm going to need to see how many times 6 will go into 25. It will go 4 times with 24. That will leave me a 1, and I will bring down the 7. 6 will go into 17 twice with 12. I will subtract that and get a 5 and bring down the 4. And 6 times 9 is 54. So when I subtract that, I am at 0. I am done with my division. That means I have 429. Now, one of the other rules when working with this particular formula is that if units are the same, like over here on the right-hand side, the hours and the hours, those canceled. However, if the units are different, over here we have miles and hours, that means we combine them. So that becomes miles per hour, or we can write that as MPH equals our rate. So that tells us that the airplane was traveling at 429 miles per hour. Okay, let's look at our next example. In this example, it says John is driving in his car at 55 miles per hour for half an hour. We want to know how far he drove. So we're going to input the quantities we're given, and we're going to use our rules for solving equations, which are to get the variable alone and to always use the golden rule. All right, so let's see what we have. Do we have distance? No, I don't see a distance. So that should be our unknown right here. Do we have a rate? Yes, we have 55 miles per hour. And do we have a time? Yes, we do. We have 1/2 hour. Now, to make this problem a little simpler to work with, I'm going to convert that half hour into a decimal, which is going to give me D equals 55 miles per hour times 0.5 hours. Now remember, we said if we have two quantities, or units, that are the same, they are going to cancel. Well, I have hours here and I have hours here, so that means those hours will cancel. That's going to leave me with just miles. Now I'm going to have 55 times 0.5, so I will multiply that over here. 5 times 5 gives me 25, and again 25, but I need to carry the 2. Add that, so it gives me 27, and I have 1 digit behind the decimal in my factors, so that gives me 1 digit behind the decimal in my product. So that will leave me with distance equals 27.5 m for miles. So John actually traveled 27.5 miles in this problem. Okay, in my last example, we have a car traveling 96 feet at 32 feet per second. We want to know how long it took. So we're going to input the quantities we're given and use our rules for solving equation. So first off, do we have a distance? Yes, we do. We have 96 feet is our distance. Do we have a rate? Yes, we do, because I see that word per up there. So that means I've got 32 feet per second. And do I have a time? No, that's what we're trying to figure out, is how long this took. So to get rid of the 32 feet per second, because I want to have the t, or time, alone on one side of the equation, I'm going to use an inverse relationship. These are being multiplied, so I am going to divide by 32 feet per second. Using my golden rule, I must do to one side what I do to the other. On the right side of the equation, the 32 feet per second cancel. On the left side of the equation, I have 96 divided by 32. 32 times 3 gives me 96. So that will leave me with 3. I've got feet here and feet here. Those will cancel, and it will just leave me with seconds. So that means 3 seconds is going to equal the time. And I have solved this equation. Now you try. There are 2 examples here for you to try. Your formula, distance equals rate times time, is listed on the page. Go ahead and pause the video, and when you hit play again, the answer will appear. Okay, on the first problem, we have distance is our unknown quantity. We have 8 miles per hour times 12 hours. All we need to do is multiply 8 by 12. That is going to give us 96. And then we're going to look at the units. I have hours here and hours here. So those are going to cancel. That will leave us just with miles. So our distance will be 96 miles. On the next problem, we have 693 miles equals an unknown rate times 9 hours. We are going to use our inverse relationship and divide both sides by 9 hours. On the right side of the equation, 9 hours cancels. On the left side, we take 693 divided by 9. 693 divided by 9 equals 77. Miles and hours are different, so we are going to combine those to be miles per hour, and that equals our rate. Go ahead and do your quick check and see how well you understood today's lesson.